Assalamu alaikum. I am Dr. Sumreen Hayat from Department of Microbiology, Government College, University, Faisalabad. Today I am going to present the topic that is biofabrication of zinc oxide nanoparticles using Acacia arabica leaf extract and their anti-biofilm and antioxidant potential against foodborne pathogens. Before moving towards my presentation, I would like to thank to organizing committee for providing me chance to present my research work here. Here is outline of my presentation. It includes objectives, introduction, methodology, results, and at the end, I will discuss about future implications and conclude my presentation. What were the objectives of the front study? Basically, we have synthesized zinc oxide nanoparticles from green source, that was Acacia arabica leaf extract. Since when we talk about nanoparticles, these are actually particles having diameter usually in the range of 1 to 100 nanometer, and because of their smaller size and high surface area to volume ratio, it has been expected and definitely it happens that their antibacterial or their biological activities would be enhanced as compared to their bulk counterpart. So that's why we focused on we focused on nanoparticles, particularly zinc oxide nanoparticles, and we have checked their antibacterial and antibiofilm potential. Moreover, antioxidant potential of these green synthesized nanoparticles was also tested by using DPPH radical scavenging assay. If we talk about why we have selected foodborne pathogens, because foodborne diseases, they have been emerged as major public health concern across the globe, and one of the estimation by WHO, it was estimated that more than 30% population, even in industrialized countries, it was affected by foodborne illnesses. And major culprits, definitely there are number of pathogens that are involved in causing such type of infections or diseases, like fungi, viruses, but bacteria, they are considered to be the major one. Particularly most important food-borne bacterial pathogens, they include Salmonella species, Escherichia coli, Klebsiella pneumoniae, Pseudomonas, Staphylococcus aureus, Listeria monocytogenes, and number of other organisms are also there. And important concern regarding these foodborne bacterial pathogens is that they are also antibiotic resistant. No doubt, across the globe, this threat has been emerged a long time ago, and the situation is becoming problematic day by day because of misuse, you can say misuse of antibiotics, overprescription of antibiotics, although warning has been also put on, but still the situation is not in our favor. And another important aspect that contributes towards the antibiotic resistance among pathogen, it is their biofilm formation. Biofilms are actually assemblages of you can say microorganisms that can form like you can say that can form that can live in a community, and they adhere to living or non-living surfaces, and they are actually enclosed by exopolysaccharide. And because of presence of this extracellular barrier, diffusion of antibiotics and other antibacterial agents, it will become difficult. That's why biofilm formers, they are more resistant as compared to their planktonic counterpart. So definitely there will be need to search or hunt for novel as well as natural antibacterial agent, and in order to cope the emergence of multi-drug resistance among these foodborne pathogens. And when we talk about alternative antibacterial agents, definitely oxides of matters like zinc oxide, they are of special interest because of their stability, safety, and non-toxic nature. In literature, you people can see a number of studies that can show biological activities of zinc oxide nanoparticles. And particularly when we talk about nanoparticle synthesis, various physical, chemical, and biological methods are there. Each will definitely will have its advantages and its disadvantages, but particularly green synthesis is considered to be eco-friendly approach. Moreover, it is also more reliable, cost effective as compared to that of physical or chemical methods that are considered to be more toxic as compared to that of green synthesis method. And in green synthesis approach, normally bacterial sources can also be used, fungi can be used, but plant extracts, more focus is on plant extract. So we use Acacia arabica leaf extract for the synthesis of zinc oxide nanoparticles. And if we talk about this plant, this plant source also has number of biological applications, particularly when we talk about their antibacterial and antioxidant potential. We have used multi-drug resistant foodborne pathogens like Pseudomonas aeruginosa, Staphylococcus aureus, and Salmonella typhimurium. And for the synthesis of zinc oxide nanoparticles, first of all, aqueous leaf extract of plant was prepared by cold maceration technique, and later on, this extract was used as a capping agent as well as reducing agent for the synthesis of zinc oxide nanoparticle, whereas zinc nitrate hexahydrate was used as a precursor. And at the end of synthesis method, we have obtained white colored amorphous product of zinc oxide nanoparticle. They were characterized by FTIR, TEM, and XRD analysis technique in order to characterize them and in order to confirm their purity. Later on, in vitro susceptibility testing was performed by using two different methods. One was broth microdilution method, through which we determine minimum inhibitory and minimum bactericidal concentration of nanoparticle, whereas agar-well diffusion method was employed to check the antibacterial potential by using different concentrations of zinc oxide nanoparticles, and diameter of zone of inhibition confirmed their antibacterial activity. For antibiofilm potential testing, two methods were used. One was qualitative method and other one was quantitative method. In qualitative assay, tube adherence method was used and in this method, particularly ring formation around the walls of test tube, it indicated biofilm formation and presence of zinc oxide nanoparticle. It actually reduced the formation of ring around the wall, or you can say reduce the thickness of ring that was formed. Whereas in microtite plate assay, basically this is quantitative estimation of biofilm formers or adhered cells. In this method also, crystal violet staining was used by using this stain. Adhered cells were stained, and then they were later on quantified. Their number was quantified by measuring the absorbance at 575 nanometer. At the end, antioxidant potential of nanoparticle was also tested by using DPPH radical scavenging assay, in which nanoparticles they were used at different concentrations, as well as standard was in the form of ascorbic acid. It was also used to check their antioxidant potential. Here are the results, and you people can see here. This is actually 10 micrograph of zinc oxide nanoparticles, and most of the nanoparticles, they were of rod shaped, or few nanoparticles they are also there that have hexagonal shape. So rod to hexagonal shape nanoparticles were formed, and the average size of these nanoparticles, synthesized nanoparticle, was around 20 nanometer. XRD spectrum of nanoparticles have also been shown here. And in XRD spectrum, well-defined diffraction peaks having two theta values at 31.72, 34.39, 36.23, and 47.44. These diffraction peaks, they confirm the presence of zinc oxide nanoparticle. Later on, FDR spectrum of aqueous leaf extract as well as nanoparticle was performed. In figure A, you people can see FTI. This is actually FTIR spectra of plant leaf extract. and B is spectrum for zinc oxide nanoparticle. And if we are going to compare them, characteristics peaks indicating presence of different functional groups have been shown here. Particularly in case of B, you people can see here a peak at 545.35 wave number, and this peak actually belongs to zinc oxide nanoparticle. Whereas another peak that is visible in case of spectrum A, it is around 3443, and this peak corresponds to free hydroxyl groups of phenols that probably used for the capping of nanoparticles. Then in this table, you can see in vitro susceptibility testing results. MIC values and MBC values have been shown. In case of zinc oxide nanoparticles, MIC values range between 31.25 to 62.5 microgram per ml, whereas MBC against all three tested bacteria was 62.5 microgram per ml. Whereas in agar-well diffusion method, there was a dose-dependent response. By increasing the concentration of nanoparticle, diameter of inhibitory zone was also increased, and maximum inhibition was observed against E. coli, whereas Staph aureus, when concentration of 500 microgram per ml of nanoparticle was used, inhibitory zone was around 26 nanometer. 26 millimeter. Then biofilm formation, to check the inhibitory effect of nanoparticles on biofilm formation by these three pathogens, quantitative as well as qualitative method was performed. Here are the results of qualitative estimation of biofilm formation by tube method, and you people can see here positive control are those cells that were not treated with nanoparticles. Ring formation was there. These plus signs are actually indicating the intensity of color of crystal violet that was observed around the pores of test tube. Whereas by using nanoparticles at sub-inhibitory concentrations, these two concentrations were used. By increasing the sub-inhibitory concentration, the ring formation, it was reduced. So it means these nanoparticles, they were effective against biofilm formation even at sub-inhibitory concentration. Then quantitative method was also employed by using microtiter plate method. Absorbance was measured at 570 nanometer, and you people can see here in case of control cell, absorbance values was high, indicating greater number of adhered cells. Whereas when cells were treated with nanoparticle, there was a significant reduction in number of cells attached to the surface of microtiter plate. At the end, we have also tested the antioxidant potential of ascorbic acid, which was used as a standard in DPPH assay, as well as nanoparticles, and different concentrations were tested. And you can see here, in case of ascorbic acid, there was a dose-dependent response in antioxidant activity. By increasing the concentration, antioxidant activity was increased. Whereas in case of zinc oxide nanoparticle, initially there was an increase in the antioxidant activity, but at highest concentration tested, the antioxidant activity was reduced, probably because of less, you can say, absorption of, or you can say lower solubility of nanoparticles. This might be happen. So we can conclude that these nanoparticles that were synthesized by using a green approach, they act as promising antibacterial and antibiofilm agents against foodborne pathogens. And these nanoparticles, they were also non-toxic. Results have not been shown here, but we have performed a toxicity assays that prove that these nanoparticles, they are non-toxic to humans as human cell line. In future, mode of action studies, they should be performed by using gene expression studies in order to find out the exact mechanism of these nanoparticles in terms of their antibacterial and antibiofilm activity. Thank you for your patience. Any question if you want to ask, let me know.